Alright, so we looked at some of the, we got some context as to the Peterson solution. We saw that there are two data entities which are going to be shared between these processes. Now what exactly does this Peterson solution propose? So we had P0, P1, right? So let's take any one process, Pi. It could be either P0 or P1. So this is the logic which that process follows to gain access to its critical section or to come out of it. So what it does is while true. So while the process is being executed, flag of I is set to true. What does this mean? This process is ready to execute its critical section. And then turn is set to J. This is for Pi. So let's say your Pi is your P0 and Pj is P1. As I said, you can have only two processes. So we'll look at things from P0's perspective. So P0 first declares that it is ready to execute its critical section, but it is offering to let P1 go first. Then while flag of J and turn equal to J. So while flag of J, meaning flag of J is true. What does that mean? The other process is also ready and the turn has been set to that process. So both conditions are being satisfied, right? The process J, Pj, is ready to execute its critical section, and the turn variable also says it is J's turn to execute now. So while that is happening, Pi will simply wait. So there is no, if you look at the while loop, there is no code inside that here. It's a semicolon, meaning Pi is simply waiting. Once that is done, now J has completed. So Pi will now enter its critical section, it will execute. Once that is done, once Pi has completed working on its critical section, it will set flag of I equals false. What does that mean? It means Pi says I am not ready to execute my critical section right now, which makes sense, right? Because it finished executing its critical section, now it is not waiting to enter that phase anymore, and then it goes to its remainder section. So the same thing happens on the other end also. For P1 also, it sets its flag variable to true. It offers the turn to the other one. While the other process is executing, this process will wait. Once the other one has finished, this process will do its critical section. Once the critical section has been completed, this process sets flag to false again, meaning I am no longer waiting to enter my critical section, and then this process goes ahead with the remainder section. Now so what is the basic logic here? First of all, once you are ready to execute your critical section, you announce that by setting flag equals true. You offer to let the other process go first. While that process is ready and you have offered the turn to that process, you will wait. That process executes its critical section. Once that one has done, control comes back to you. You will execute your critical section. Then you will say you are no longer ready. Then you will go to your remainder section. So once this is done, how is control coming back to you? It is because in the other process, the process sets flag of J equals false. So this is no longer true. So this loop is broken. So control comes to I. Turn will be set to I, and I's loop will, or I's critical section will execute. So this might look a little like a loop kind of a situation where one is offering to the other is offering to the first one. So it might not be very easy at first glance to make sense of where is this beginning, where is this ending, how is control switching back and forth. So the idea is, let's say initially one process is ready to execute its critical section and the other is not. So let's say process I is ready, process J is not yet ready. So process I will set flag equals true. So it's declaring I am ready to deal with my critical section. Yet it is going to offer the turn to J. Now we assume J is not ready. So this part is false. So this condition does not happen. So I realizes, okay, the other person is not ready. Let me go ahead and finish my job because I am ready. So I will execute its critical section. Then it will set its own flag to false. Meaning it no longer wants permission to execute the critical section. Then I will go ahead with its remainder section as usual. In the meantime, if J has been ready, then J will set its flag variable to true. The turn will again come back to J. Now flag of J is true, the turn is offered to J. So J will now work. Once J has done, J will also set its own flag to false. meaning J no longer wants to go into the critical section, then it will go on to execute its remainder section and J will offer the turn back to I. So both of you keep offering the chance to one another back and forth, and whoever is ready and has also been offered the chance will pick up, the other will wait, and the cycle continues. So that is the basic idea of the Peterson solution. Now, because your turn is a binary variable, it can only be 0 or 1. That is why your Peterson solution works only for 2 processes. If you have 3 processes, then with 0, 1, 2, if your turn variable is going to take values like 0, 1, 2 up to n, then it will become very complicated for the control to shift. So now if you have only 2 processes, I offers control to J, J offers control back to I. If you have 3, then whom should I offer control to, whom should J offer control to? All that confusion comes into place, right? Which is why the Peterson solution is restricted to 2 processes. So that is how the Peterson solution works.